and what is the importance of each task there. Just a moment, I will prepare something here. So the task is here, and like you remember, your job is to design this rotor for this rotary feeder, so that you will use some standard parts like the frame and the ends and the sealing and also the bearing and the gear motor. You don't have to design them, but you need to design a rotor so that it fits together with other standard parts. And one main point in this assignment is to understand or to do the design for manufacturing and design for manufacturing and assembly, so that all the things that you design should be done in a way that the manufacturing would be as easy as possible, and all the steps, all the stages, what you have in your design, they should be based on the same steps and same stages what happens in a manufacturing. And for each manufacturing step, you need to have a separate document so that the person who is responsible for this certain manufacturing step, they have just one document, and they don't need other information at that moment, but they need to have that information what is essential for proceed this task. And roughly the tasks or the steps are here. So in a manufacturing point of view, if we are talking about the rotor, the first thing is that we need to cut certain plates. And to do the laser cutting or flame cutting, you need to have a DXF files. So they are not normal drawings, but they are, you can create them directly from 3D model, but they need to be saved in a DXF format, because these laser cutting machines and all other similar machinery, they use this DXF format to read information. And based on this geometry information in this DXF file, they will cut the part in a shape you want. And in this case, these blades and end plate need to be laser cutted out of the big plate. And also this shaft coarse machining, it's kind of a preparing step. It is preparing the shaft for welding. I showed you last time that you need to create a shaft with certain shape. And the reason why this certain shape is there is that it makes more easy in an welding point to put the end plate in a correct place. The welder don't need to do any special, very accurate measurements, but if there are machine plates on a shaft, he or she can just put the end plates in a correct place and weld it without so much measuring. So these steps 1 and 2, they are kind of a preparing parts. Then step 3 is development. This is a place where you weld all things together, and you need to have a separate weldment drawing. And then step 4, after development, you have to machine the rotor so that it will get the final shape. Sorry about these. The final shape means that you need to have certain quite accurate tolerance here, and you need to have a quite accurate surface roughness or quite smooth surface roughness. And also you need to create this kind of keyway here. And each of those surfaces, roughnesses, tolerances, and shapes, they are so accurate that you need to do them after the welding, because the welding is a process where you put quite high amount of heat in the structure, and there can be some deformations. And if you would have done all this machining before welding, it might be that after welding they would not be in a correct tolerance anymore. That's the reason why this final machining is done after welding. And also we need to make sure that there is enough material so that we are able to reach the tolerance. For instance, if we have a look at this output diameter, which is 250, in this preparing, we need to create a part which is more than 250, so that after welding, we can be sure that we have a material that we can remove, so that we can reach the tolerance, we can reach the surface roughness without any problems. So we are not able to use in this DXF step this exact diameter, but we need to have a little bit more, couple of millimeters more. And then here the final step is to assemble all things together in a rotary feeder. And last week, well, not last week, but last time, we started this, and then you need to go to virtual desktop. And one more reminder now, so that everything works in a proper way in SolidWorks. When you open this virtual desktop, you need to run SolidWorks settings every time again. And you need to run the correct SolidWorks settings, which can be found from Moodle under this course. Wait a moment, here. Under the topic PDM systems, there is a file called SW and Custom Work Settings 2021-01-19. This is the most latest settings file for SolidWorks, and you should run this file in a virtual desktop every time you open that one before you run the SolidWorks. And it would be smart to copy this to your virtual desktop so that you don't need to get it from Moodle, but it would be here in your desktop so that you can just double click the file and say that yes, I want to run this one. Actually, that was the correct one. And after that, you can open the SolidWorks and all the settings should be correct so that you are able to use custom works, you are able to use PDM, and all the drawing sheets are correct.
Sim, does it have any conflicts with other settings? Because I used to run both this one you sent to us and also the one Eero sent to us. Like,
I think it might be that mostly I know that this file that Eero has sent you, it's more or less the same because we have created the settings file together with Eero. There might be some very small difference, but there should be no conflict.
Okay, so it's better to run one of those files.
Yes.
Okay, great. Thank you.
And I don't know how many of you already saved the file in PDM, but I saved my example file in PDM, so I'm going to open it. From there, and I made some changes now so that now you should not see anymore all the courses what are here, but you should only see the Machine Design 2021. Can you confirm that this is the case?
Yes.
Okay, good. And you can create your own folders like some of you have already done, and you can save this assignment under your own folder. So here under my name, there is this assembly of the rotor and assembly of the rotary feeder. And if you wonder why you see only assemblies and no parts, there is this quick filter which seems to be in an by default works so that only assemblies are shown. So if I remove this filter, then I see also the parts which are under this folder. But maybe in an opening stage, it makes sense that you see only assemblies. Okay, I will open this main assembly. And next there will be a question, most likely that do I want to, okay, something related to whole wizard. No, I don't want that it will be taken from PDM. But this one, now it is very important to understand this check out and check in, like I have said several times. So these are the main functions when you work with PDM. Check out means that you will take the rights to modify certain documents, and check in means that you will send the information to the server, to the PDM, which is saved there. So I am able to open documents without checking out them. But when I do the checkout, then I kind of own the documents and I'm able to modify them. And now this is the case. I want to open my main assembly. Then if we have a look at these two parts here, it says no checkout rights. Why is that? It's because these documents are the standard parts of this rotary feeder, and they are not able. I'm not able to take them because they are in an approved stage, and this is how it can be. I don't want to modify them, but I want to modify this rotor. I'm just thinking that am I able to take description here visible so that it would be more easy to see what are these things here. Now I see that this is the rotary feeder assembly, this is the frame, this is the drive end, this is the rotor, shaft, and end plate. So these three are the things that I want to modify, and I want to check these boxes that I want to check out them. Okay, and here it is in a stage that I left it last lecture. And maybe now it's good time to stop here and ask that what is your situation? Have you managed to do similar things, or do you have any problems where you would need my help?
Well, I have a question.
Yes.
And how we can know the correct measures? I mean, the correct values.
At the moment, you don't know the correct values yet. As you can see, my rotor is not having the correct fit at the moment. But when you later attach a bearing here, and you will attach the sealing unit here, then you know that what are the correct dimensions. And also in the other side, later you are going to select a gear motor here, and then based on those dimensions that comes from the standard parts, then you are able to modify this rotor to be correct.
Okay, thank you.
So at the moment, this is just an that was my way to do it, that I just randomly gave some dimensions there, but it might be more smart to first do a lot of measurements and then directly put the correct dimensions there. But I didn't do that way last time. And actually, I noticed that the way how I created this shaft is not maybe the smartest way in this case. Because if I have a look at these dimensions, what I have here, I have the overall length, and then I have these 200 millimeters remove from each end, but it would be more smart to have a dimension here so that I could say that this is this 250. Now I need to calculate it in somehow or create some formulas. And I was actually a little bit thinking that I could change this one. I don't know how much problem it causes, but anyway. I actually could try it. I will modify. Maybe it would be even more easy to create just a fully new part compared to modifying this one. Actually, I could try to make a new part. Let's see what happens then when I try to replace it. So a new part. In a front plane, I want to create a sketch. Okay, let's start from here. Then I want to say that this one is 80. And now I'm able to say here that this one needs to be this 250. And then I can say that this line and this line are collinear.
Simon, could you please show again how did you do like this diameter?
You mean these ones?
Yeah.
So if I want to give a diameter between this or dimension between this and this, it depends the place where my mouse is. If my mouse cursor is above the line, then it shows only half of the diameter. But if I move my mouse below, then it changes to the diameter instead of radius.
Oh, okay. Pretty simple though. Thank you.
Yes.
So it will work also with the drawings, right?
Yes, I believe so.
Okay, great. Thank you.
But now I want to give one more dimension here, this full length, because I need to use this one in my custom works. And I can create this to be driven. it will change if I change some values here, but still this is something that I need. And now a revolt POS. Now it's there. And now I need to give this basic information for it. Run bar. Diameter, maximum diameter here is 70, and now this is the dimension that I need, this length. And the material, for example, this S355. Now I have everything. And then it was important to save it in PDM with the help of this save button inside CustomWorks, because then it uses this item number as a name in this part, and this is exactly the way I want to do it. And still, it is important to understand that even though I press the save button now, and there is this announcement that successfully added one file to Vault, still the part is not checked in to PDM, which means that if I now would close the SolidWorks and log out from the virtual desktop and come back after 1 hour, I would have nothing there, because this is not really checked in. But you need to do this check-in operation here. And if this is gray, like it is now, one option is that it is not selected. So you need to press a button here. And if it's still not going to help, you can save the document once more by pressing this save button or pressing Ctrl and S. And most likely after that, this check-in button appears. And now when I press this check-in, and I want to continue working with this, that's the reason why I also select this keep checked out button. And then finally check in here. And now it is in a safe place. Now it won't disappear, even if I log out from virtual desktop. Okay, now I have a new shaft, and now I'm going to see whether I'm able to change it, replace it. This might not work in easy way, but I want to try. If when I have an assembly, I can use a tool called replace part. Replace components. Wait a moment. Why there was a selection already? This is something that I don't want to do. replace. Okay, now the shaft is replaced with, I think this, what was the name of this new shaft now? I'm not able to remember it. Okay, it is this, which is ending 779. So I want to change it with this 779. Oh. Or maybe it is, okay, sorry, the 779 was the original part, and the new one that I just created is this 839. Yes. This was the thing that I was accepting, that there are some problems. Maybe it's just easy to delete all the mates. Because it's not going to recognize the same same faces as what I had in this original shaft. Okay, so now they are concentric, but I need to also modify these coincident mates. Okay, now it's there. And now with this part, you can see the thing that I told you, that this main diameter, it's more than what we would need at the end. So we would need 250, but now we have 255. This might be a little bit too much. I think 2 or 3 millimeters would be enough. So maybe I can change this now. I will remove 2 millimeters from here. And another thing is this hole. So you see now that there is a gap, and I want that there is a gap, because now the first step is that in this assembly is the welding, and I just want that these pieces are very easy to put, and they would be slide until they hit this face here, and then a welder is doing the weldment, and it will fill the gap which is here. Although it seems that this gap is maybe a bit too big at the moment. So the diameter here is 77 and the diameter here is 70. So definitely this is too much. I think that in this original shaft that I had this dimension was not 70, but it was 75. So I will also modify this to be smaller, not 77, but for instance 72. So that it will be 2 millimeter more than the shaft. It means that it is still easy to slide, but the gap is not so huge.
So how much is the gap now?
It is in a diameter 2 millimeters.
So we just subtracted 2 millimeters again.
Yeah.
Right. Okay.
All right. So let's see what problems I have in a main assembly now. Because I changed the shaft, it might be that also here I face some problems. Yes. A concentric mate.
Should we check in the rotor feeder before we go to the main assembly?
Not necessarily, you can do it later, but if you want, you can do it.
Okay, great. Thank you.
Okay, now it's there. And now the rotor has the correct dimensions from the middle, as you can see here. Maybe I will do the cut. Sorry, I cut it with the wrong plane. This is the correct one. So now the distance between this plate and this plate is exactly the 250, which is the distance between this and this. And now this rotor dimension, rotor length from the middle is correct. But of course, what you see here in the left side and what you see on the right side, they are not correct. In other side, you need to attach a bearing, and in other side, you need to attach this gear motor. And the ceilings will become in this point and in this point. But before we can start designing these dimensions, we should make the weldment assembly ready, which means that you need to put the plates here in a rotor. And that's the thing that we can do next. I will just modify this a bit so that it is not symmetric, because it's not going to be symmetric in real life. So I add some material to other side. That was maybe a little bit too much. Okay. It can be as it is now, and I will go back to the rotor assembly. And the next thing what I need is the blade. And the height for this blade, this was this 253 at the moment, and then this one is 80 millimeters. So the height for the blade is starting from this point, from this surface up here, which means that it is this 253 divided by 2 minus half of the shaft. So it's something like 86.5 millimeters. So I will create a new part. Which is the simplest possible part. Because it's only a rectangle. The height is 86.5 and the length is 250. And if I remember correctly, all the parts should be 8 millimeters. And once again, information needs to be given in CustomWorks. And the material. I was just thinking whether there was a place here, manufacturing type, item type. Well, I think in some factory or in some company, they could use this kind of classifying between the parts, but I think this would have been a, maybe you can call it a sheet metal, maybe not, because it would be, I think it would need a separate class called cuts or something like that, which we don't have at the moment, so I'm not going to select anything here. It depends on the companies whether they use this kind of classification or not. And I save it in a safe place inside PDM. And then in a rotor, okay, this is something that I can close. This was the old one. And now this blade needs to be put here. And this would be a very easy case if it would be just straight put here, I can show if it would be put directly like this. Oh, now I made a mistake. Front plane from here and front plane from here and coincident like this, and then I could say that this one and this one is fixed, and then I could say that this one, this surface and that surface would be tangential, touching each other. So now the blade would be there, and then I could just say that circular component pattern between or over this one and equal spacing and 8 pieces. Or was it 6? Components to pattern, this one. And it would be here. But unfortunately, this is not the case, because in this original assignment, it was told that this blade needs to be in 5-degree angle. So it's not attached in a way, but it needs to be inclined so that there is a 5-degree angle between the blade and the shaft. So it's a bit more complicated.
Like, how can we understand what is meant by 5-degree angle between blade and the shaft? Isn't it always like perpendicular?
It's just something which is related to this rotary feeder. It's not something that you would be able to understand by default, but this is just information that I tell you, that if we have a look at this assignment, it was told here that blade angle is 5 degrees, and in the case of